Day 822 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1406, Stone Game 3. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Alice and Bob continue their games with piles of stones. There are several stones arranged in a row, and each stone has a value associated. Each stone has an associated value, which is an integer given in the array stone's value. Alice and Bob take turns with Alice starting first. On each player's turn, that player can take 1, 2, or 3 stones from the first remaining stones in the row. The score of each player is the sum of the values of the stones taken. The score of each player is 0 initially. The objective of the game is to end with the highest score, and the winner is the player with the highest score, and there could be a tie. The game continues until all stones have been taken. Assume Alice and Bob play optimally. Return Alice if Alice wins, and Bob if Bob will win, or tie if they will end the game with the same score. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input stone value equals an array of integers 1, 2, 3, 7. The output is a string Bob. That means Bob will win the game. It says Alice will lose. Her best move will be to take 3 piles, and the score becomes 6. Now the score of Bob is 7, and Bob wins. So once again, it says Alice and Bob take turns with starting with Alice first. On each player's turn, that player can take 1, 2, or 3 stones from the first remaining stones in the row. So she could take these 3, she could take all of them, right? But it still won't add up to 7, right? And that's her first turn. Bob will come get the turn after that. So the most amount of points that Alice can get, the most possible amount of points that Alice can get is 6. Bob's going to get 7 just because he gets to go second. So that's why Bob wins. Now, just in case that didn't make sense, let's take a look at example 2, where it's kind of the opposite. So in example 2, the stone value equals an array of integers 1, 2, 3, -9. This time, Alice wins. It says Alice must choose all 3 piles at the first move to win and leave Bob with a negative score. So in this case, it's like the opposite of this one. Alice takes these 3, she has 6, and Bob is forced to take this 9, which is a -9. It says if Alice chooses 1 pile, her score will be 1, and the next move, Bob's score will be 5. And the next move, Alice will make the pile with the value of -9 and lose. If Alice chooses 2 piles, her score will be 3. And the next move, Bob's score becomes 3. And the next move, Alice will take the pile with this value of -9 and also lose. It says, remember that both play optimally. So here, Alice will choose the scenario that makes her win. So all this is saying is this right here. Let me see. Oh, right here. This is the move that Alice has to make because the players are playing optimally, meaning that it's guaranteed that the players are playing to win. So, since we know that it's guaranteed that the players are playing to win, then boom, we take these 3 right here, and then we force Bob to take this, we force Bob to take this -9, If we take just this number or we take these 2 numbers, Bob can take this 3, and then Alice will be forced to take this -9. So really, it's all about who can force who to take this -9. And in this case, since Alice goes first, she can force Bob to take the -9. Now, just in case that didn't make sense, let's take a look at example 3. So in example 3, the input stone value equals an array of integers 2, 3, and 6. This time it's a tie. Explanation says Alice could not win this game. She could end the game in a draw if she decided to choose all the first 3 piles. Otherwise, she will lose. So in this case, the only way for Alice to win is to take these first 3 piles right here, and then she'll have 6. Then Bob will be forced to take this 6 at the end, and the game will end in a tie. So boom, y'all, I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution, y'all. The solution is not that difficult at all. So, all right, so the first thing we're going to do is we're going to get the number of stones in the game by saying let n equals stone value dot count. Boom. Now we need to create our rolling dynamic programming array. So we're going to declare a variable called dp and set that equal to an array of integers. Come outside of that, open up the brackets. We're going to say repeating colon 0, comma count colon 4. Boom. Now we got to work backwards so that the results for future positions have already been computed. So we're going to come underneath this. I'm going to say for I and stride, open up the parentheses from colon n minus 1, comma, through colon 0, comma, by colon negative 1. Now we need to track the best score difference the current player can achieve starting at index I. So we come outside of this, we're going to open up the brackets, and we're going to declare a variable called max relative score, set that equal to int.min. Boom. Now we need a running sum of the stones taken this turn. So we declare a variable called sum, and we'll set that equal to 0. Boom. Now the player may take 1, 2, or 3 stones, so we're going to say 4kn 1 dot 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 3. We're going to open up the brackets and we're going to make sure we don't go past the end of the array. So we're going to say if I plus k minus 1 is less than n, we're going to open up the brackets and we're going to add the next stone to the running total by saying sum plus equals stone value square bracket I plus k minus 1. Boom. And if the current player takes k stones, they immediately gain some points and the opponent starts at position I plus k. So since the opponent's advantage becomes our disadvantage, we're going to subtract it from the points we just collected. So we're going to come right here underneath this. We're going to say max relative score equals max, open up the parentheses, max relative score, comma, sum minus dp square bracket I plus k. Actually, this I plus k needs to be in parentheses, so let's go ahead and wrap that in parentheses. Then we'll come outside of this parentheses, still inside the square bracket, say mod 4. Now, we need to store the best possible score difference for index I, so we'll come right here, and we're going to say dp square bracket I mod 4. Come over here, and we're going to set that equal to max relative score. Boom. Now DP is the maximum score difference Alice can achieve starting from the first stone. So a positive score means Alice wins, a negative score means Bob wins, and if it's a 0, then both players end with the same score or it's a tie. So we come right here, we say if square bracket, or excuse me, if dp square bracket 0, come outside the square bracket, is greater than 0, we'll open up the brackets and we'll return a string Alice. Sorry, y'all, Alice. Boom. Then we could really just copy and paste this, bring it over here. We change this to less than, and we'll change this to Bob. Then we'll come underneath this, and we can say return square bracket tie. Boom, y'all. So let's give this a run. Make sure it runs properly. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 7 milliseconds beats 75% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, y'all, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.